Okay, so this video we're going to be focusing on proportions. So we're going to be looking at proportions, which is a big part of this chapter. So what is a proportion? Well, a proportion is an equation stating that two ratios are equal. So when we're talking about proportions, we're talking about having ratios that are equal to each other. Now, we know what an equation means. We know that when we have an equation, we have an equal sign. So anytime that we're talking about proportions, we need to have an equal sign showing that those two are equal. So we have the example here, 6 over 8 is equal to 9 over 12, or 6 to 8 is equal to 9 to 12. Those are two ratios that are equal, so they form a proportion. Now, one way to see if ratios can form a proportion is to write both ratios in lowest terms and see if they are equal. So we can think of these ratios as fractions. And really, when we're talking about ratios from this point on, anytime we're writing a ratio, it's going to be in the form of a fraction because that's going to be easiest for us to work with. So one way to check and see if these two ratios form a proportion is to see what both of them look like in lowest terms. And if they're the same thing in lowest terms, then they can form a proportion. So I'm going to simplify each of these ratios. So I'm going to start with 4 over 10. If I divide both sides by 2, so divide by 2, divide by 2, I end up with 2 over 5. And if I do the same thing over with 6 over 15, I can divide both by 3. 6 divided by 3 is 2, 15 divided by 3 is 5. So I end up with 2 over 5 for the left side. I end up with 2 over 5 for the right side. So I know that these are equal. So yes, they form a proportion. Okay, there's another way to prove if ratios can form a proportion, and that's to show that you have a common multiplier that connects the numerator and the denominator. So this is like writing equivalent fractions. Is there a number I can multiply or divide both the numerator and the denominator by to go from one ratio to the next? So if I'm starting with 4 over 5, is there anything I can multiply both 4 and 5 by to get our next ratio? So I'm going to think to myself, okay, if I multiply 4 by 8, that is 32. So in order for these to be a proportion or to be equivalent, I would need to multiply the bottom by 8. So if I multiply 5 by 8, does that equal 40? Yep. So I know that these are equal. So yes, these form a proportion. And the last way, and really the most important way for us to see if ratios form a proportion, is through something called cross products. And we've seen cross products or something similar to cross products before when we cross multiply. So cross products are found by multiplying the denominator of one ratio by the numerator of another ratio. So it's found by multiplying the denominator of one ratio by the numerator of the other ratio. So if I have two ratios here, I'm going to multiply the top one by the bottom and multiply the bottom one by the top, and then I just check to see if they're equal. So let's look at an example here of that. Okay, I have 6 over 8, and I want to see if it's equal to 9 over 12. So I want to test to see if these are really proportional. So actually, I'm just going to erase that, because I shouldn't know if they're equal yet or not. So what I'm going to do is I'm going to use cross product, meaning I'm going to multiply the 6 times the 12, and then I'm going to multiply my 8 by 9. So let's multiply 6 times 12 first. 6 times 12 is 72. And then I'm going to multiply my 8 times 9. 8 times 9 is 72. So now when I'm looking at them, if these form a proportion, or if these are equal, these two numbers should be the same. And 72 is equal to 72. So yes, these do form a proportion here. 6 over 8 is equal to 9 over 12. So let's move on. Now, we want to use cross products to determine whether the ratios form a proportion. Again, this is really the important part right now of this section or of this video. We want to make sure that we can use cross products and know how it works here. So in this case, we want to use cross products to determine whether these two ratios that were given in the example can form a proportion. So let's look at example A. I have 3 over 8 and 6 over 16, or 3 to 8 and 6 to 16. I want to see if these are proportional or if they are equal. So I'm going to use cross products here. And I know that there's other ways we can do it, but again, our goal is we want to make sure we know how cross products work. So I'm going to multiply 3 times 16, and then I'm going to multiply 8 times 6. I'm going to start with 8 6 first, since that's one I just wrote down. 8 times 6 is 48. Okay, now I need to multiply the other side. 3 times 6, and 3 times 6 is 48. So now I need to think to myself, is 48 equal to 48? Yes. So do these form a proportion? Yes, they are what we could call proportional. Okay, let's do the same thing with 4 to 7 and 5 to 9. So I'm going to multiply 4 times 9. And 4 times 9, I'm just going to do that right now, is 36. And now I'm going to do the same thing with 7 times 5. 7 times 5 is 35. So now I need to compare. Is 36 equal to 35? No, they're not equal. So no, these are not proportional. They do not form a proportion.